Hi Rocco, happy Friday. So I'm going to try and explain my robotics unit as I'm not entirely sure how to share this because I could share like a copy of the page, but it wouldn't have the live links and all of the other stuff in it because it's in the OneNote notebook. So how the robotics unit starts is the students learn how to edit videos in iMovie so that they are ready to make videos that they're going to end up publishing to pass information from group to group to group to group. So the first thing is they get a rubric of all of the different roles. There's groups of 4 during this unit, and the 4 roles are organizer, understander, resourcer, and includer. And each of them have specific jobs for them to accomplish every day so that they are all tackling the different tasks at hand, such as timekeeping, organizing, or making sure the parts are all in the right place, gathering supplies, video making, editing the video, all sorts of different stuff, putting it in iMovie, uploading it. So all these different jobs the students learn over the course of a couple of days, a little at a time, as they learn a little bit about the video making and some of the parts that they're going to be using. Then they get one partner that they can choose, and then I pair 2 different groups together, usually people that don't know each other, so that they can practice being comfortable being uncomfortable and working with new people, potentially even people that they don't like, so that, in the workforce, that's a skill that I value and I think that's important for them to learn. So then all of them get paired into a group. So there's a total of 6 groups that I have, and I theoretically could do more. I'm considering groups at 20 next time, but it just means more parts, and I'd have to see if I have enough. But as of right now, I have 10 different classes working in the same kit, and these are all the kids working on group 6, as you can see over here, so the build for group 6. And there's a lot of different things that I would like to do in robotics, but because of the amount of content and curriculum that I teach, I only have time for one main build. So the build that I chose was the one that I believe I just emailed you, that so in here there's a Clawbot kit over here. So this Clawbot is a pre-configured kit that is what I have them build, and there's a lot of different learning that they're doing during this. So going back over to OneNote. So they get into their groups of their 40 members, and there's 4 people per class, and these students learn those roles, and then they are going to start working on the construction guide that I give them. So I give them over here a step-by-step construction guide that is, I believe, 20-something steps long over here, and they are trying to build this at their own pace as much as they can every period. And they start on step number 1, so period 2 starts building, and they work on whatever they can. And wherever they stop, they have to pass the message to the next group on. Sometimes students will make comments over here or write questions in it for things that they can't figure out and tell it to the next group. And then all of that is published in a video that they create for the next class. So I have the video log over here where the kids say the time and date, then they make a video, upload it to iMovie, put subtitles, edit it, and they do this the last 5 minutes of class, so the videos really should only be about 30 seconds long. It's a very quick process, and it's a steep learning curve, so the first 2 weeks the videos aren't so great, but they get better. And in order to get better, the students, the next group, so this is period 5 over here, responding to period 2, and they write feedback in order to help them. And then that feedback helps them make better and better videos. And this part over here, also during the robotics unit, I just got a class set of Apple Pencils, so I was teaching the students how to use the Apple Pencils at the same time as doing the robotics. Because I think handwritten feedback, at least compared to typing, really stands out from person to person to person, and when you handwrite something, it kind of sticks in your brain a little more. So we have over here the video log, so every period the students make these videos, they post feedback, and they're working on the builds, and they highlight things that they can't do so the next group can try and do it, and they keep going as the project keeps building and building until they get all the way through the whole builds. And then we talk about at the end how this is never done, it's simply functional or not functional, because after this they are going to move on to the coding part of this unit, And in the coding part, they get the new rubric with the specific roles, same groups, and they get the coding challenge over here where they have a document with the group where they are going to start by learning how to code and how to set up all the sensors so that the code, when fully written, is actually able to be downloaded. And they're going to complete maze challenges with the clawbots out in the hallway where they code different challenges and try and solve them. And in order to prepare for the code over here, I use a website, which is the Robot C tutor over here. And this is Robot C's language for Vex. And it's an online website, but it's programmed to give hints, and they work through this before they start the actual coding process. And when they finish the movement fundamentals, they finish the Robot C rules over here, movement fundamentals, and then instead of doing the labyrinth challenge online, they do the real labyrinth, which is the one that I was just showing in the hallway over here. So the students then work, instead of amongst the 40 people, they just work with their group of 4, and then they post their code so that every group has the code as an option, and they can kind of comment on what they did right and what they didn't do. And like over here, they're highlighting that that's the part that didn't work on it, but then the next group can come in and write their own code, but just take the code that the last group saw, and they can use that for feedback on like what to do or what not to do. But everyone starts from scratch for these coding challenges, and they save the code over here. And by that point, we're basically out of time for the semester, but if I had more time, I'd love to dig deeper into different challenges in coding, and even, just not just building the clawbot, but doing different builds, because there's an infinite number of things that the kids could build. And I could always work in building like a second construction guide from scratch. I mean, for example, I taught the kids with Apple Pencils how to create something like this with a hand-drawn part list where these parts I drew, and then I'm teaching, like this was a student drawing, but they're learning how to kind of draw like a schematic with the Apple Pencil and the iPads over here. And it's basically digital tracing, which was done with the original part list over here, which they zoom in and they go to the draw tab and they trace over it, which is exactly how I made the hand-drawn part list. And then these sketches can go into, for example, like the purpose log over here, where they're learning about the purpose of the parts and they're questioning stuff over here. This part needs a little bit more refinement because, as you see, the kids didn't really fill all of this out last time. It was a bit much. And then also I have just a question log, which again needs to be refined a bit because I wanted the kids really thinking. I didn't explain a single thing in the robotics unit. I didn't tell them what any part did, why they were using the parts. I wanted them to ask questions and come up with it. So I want to continue to tweak and make this part better also. And the final thing is, annoyingly, this doesn't exactly work, but I had the idea of using like 3D modeling for the kids to get like a copy to manipulate. So I found a website that has, for example, the clawbot over here as a fully built 3D model, but the problem is the kids have iPads, and when you open this on the iPad in the 3D viewer, it just glitches out. So I really want to use some sort of CAD or 3D model or augmented reality or some sort of that with the unit, but it's fixed. Okay, that's awesome. Yeah, so I have this it wasn't working last time. I guess they improved it, but they can use this to help them see like what it should look like when it's done, and they can zoom in and see all the parts. And something like this I'm also considering having them do with the e-learning that we're right now doing, but I just don't know how to have them like digitally build something with like digital parts. Like maybe they can somehow build this digitally in 3D modeling. I don't know, but that's basically my robotics unit and what I have over here. And I'm happy to share this with you. As you can see, it's a little bit all over the place right now, just because I've some organizing and thinking to do on how to improve it, because it always gets changed a little bit. But let me know if you have any questions. Yeah.